That thrum you hear is the sound of science at work. It's coming from magnets, some of the most powerful in the world.
So we are indeed a world-class facility. There are many different kinds of magnets, superconducting magnets, big resistive electromagnets, pulsed magnets.
With support from the National Science Foundation, the National High Magnetic Field Laboratory, MagLab as it is called, is a mecca for groundbreaking research across scientific disciplines.
So I direct a very unique laboratory to bring high magnetic fields to researchers who come to our lab every year to study important research topics in the areas of materials, of energy, and of life.
Now, I know when you hear magnet, you're thinking about something like this. But the magnets here are of a different kind altogether, millions of times more powerful than anything you would stick on your fridge.
You should think of a high field magnet, a powerful magnet, as a research tool, much like a high-powered laser is being used by scientists, much like an atom smasher. We're a research tool.
Analytical chemist Amy McKenna is a staff scientist working on the ion cyclotron resonance magnet. She's all about oil, how to refine it more efficiently, and how to better clean it up when it spills.
Every crude oil in the world is unique. It is a function of the temperature, the pressure, and the organisms that died and created that mixture.
Petroleum is what's called a complex mixture. Think on the order of 40,000 different chemical compounds in every drop.
We analyze the compounds in crude oils, in dissolved organic matter, in water, and we measure their mass very accurately.
To do it, this magnet functions as a highly precise molecular scale.
In order to measure molecular weight, you need these types of scales. And that's what we do here, is we measure a fundamental property of molecules very accurately, to 6 decimal places.
In another part of the MagLab, physicist Corey Dean is using the DC field facility to research the properties of a relatively newly isolated material called graphene. It's a flat sheet of carbon molecules laid out in a chicken wire-shaped pattern.
It's unique in almost every metric that you can define. It's been called the strongest material, it's the thinnest conductor, it has one of the best thermal transport properties.
It's so unusual, in fact, that physicists are still trying to figure out the basics of how it works.
One of the things that we want to know is when we put this device in the presence of a very large magnetic field, combined with very low temperatures, both of these things are critical. Can we access what we call the quantum properties of this material?
That level of understanding is needed before engineers can really start making things out of graphene.
We can discover, for example, new electronic behaviors, which to a physicist might be very interesting, but to an engineer means that you can design a brand new material that maybe solves a problem that is facing challenges for like how to make a better computer, for example.
Dean is one of nearly 2,000 scientists from institutions around the world who use the MagLab facilities every year. Magnetic field testing can benefit many fields of research, petroleum and materials for sure, but also human health and medicine, batteries, biofuels, and much more.
So we know how to bring in newcomers to high magnetic field research, help to make their experiments successful so they can then publish their results and get the information they're seeking.
Visiting scientists don't even need to have experience working with magnets. All they need to bring is a worthy project. Experts like Amy McKenna are on hand to help.
That's the crux of a successful user facility. You've got to have the magnets, you've got to have the instrumentation, but most of all, you've got to have the talented people.
Putting the power of high magnetic fields to work, breaking through the boundaries of scientific knowledge. For Science Nation, I'm Miles O'Brien.